Good morning, students. So today we are going to discuss about soaps and detergents. This is our last topic of fourth unit. Okay. So in this topic we are going to discuss about soap and detergent. Okay. So first of all, soaps. Soaps are sodium or potassium salts of long chain carboxylic acids. Now see, you know what are carboxylic acids? Carboxylic acids are those in which this is the functional group. Okay, so if we take long chain carboxylic acid and we make its sodium or potassium salt. Sodium or potassium salt means in this functional group we have to replace this by either sodium or potassium. So if I write like this, COONA, okay, then this will be a functional group for soap. Okay, now this will be connected with long chain. Long chain means it will be this R will have so many carbon atoms, just like it may be 15, 17 or more than that. Okay, so in general what we can say, that formula of soap is RCOONA. Okay, so this long chain, how we express it? We express this. Okay, this is zigzag form. Here, this is also carbon, this is also carbon, this is also carbon, this is also carbon, this is carbon, this is carbon, this is carbon, 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 and carbon. So every end and every bend represents carbon. See, in this form, when we see every end and every bend, that represents carbon, and this length that represents the bond. Okay, so in general, diagrammatically, if you want to say, then this way, this is the long chain of carbon atoms. Okay, and this is the end where there is charge, just like I showed you that this is the formula of soap. So it will be like this, RCOO negative and Na positive. When it will ionize in water, then this will be the active part of soap. So COO negative, this end represents COO negative. So because of negative charge, we say that this is hydrophilic end. Okay, and on the other end there is no charge, so that is hydrophobic end. Philic means attracting, phobic means hating. So hydrophilic means this end is attracted towards water. Water is also polar, so this is polar end, and like dissolves like, means similar nature will be attracted towards each other. Okay, so this is our hydrophilic end and this is hydrophobic end. So this end will remain away from water and this end will be towards water. Okay, now when we talk about soap, formula of soap I have just discussed, and this is the structure representation of this. Okay, now this thing is used for removal of dirt. So what is there in dirt? In dirt there is presence of oil droplet. Okay, so this type of chains, this type of molecules, they form misli. Okay, what they do? They form mislis. What is mislis? This in next slide you will see. So because of formation of misli, the mislis help in pulling out the dirt in water, and so our clothes get cleaned. Now how do we do it? Let us understand. Soaps are molecules in which the two ends have differing properties. One is hydrophilic, that is, it interacts with water, while the other end is hydrophobic, that is, it interacts with hydrocarbons. When soap is at the surface of water, the hydrophobic tail will not be soluble in water and the soap will align along the surface of water with the ionic end in water, and the hydrocarbon tail protruding out of the water inside water. Okay, now see what we want to say. See, this thing is cloth which is to be washed. Okay, and this part is the oil part which is present on the cloth and that is to be removed. Okay, now what we do, when we dip it in soap solution, then what happens, these molecules are of soap. Okay, this dark portion is hydrophilic end, means this end is attracted towards the water. Okay, and the blank one, this portion is hydrophobic end, means this is attracted towards oil drop or dirt. Okay, now when we dip it, then what happens, this hydrophobic end, it starts attaching itself with the grease or oil or dirt. Okay, now because of this, what happens, when this starts, then there is formation of misli. Okay, this is formed. What is this? This is called misli. Now what is misli? See, this yellow portion which you are able to see inside, this is the dirt or it is oil droplet. Okay, now with this, these many molecules are attached, so many molecules have been attached with this. Okay, now when these have attached with this, then what happens, there is cluster of molecules, in which the hydrophobic tails are in the interior of the cluster and ionic ends are on the surface of the cluster. Okay, and this formation is called misli. This combination is called misli. Okay, now what happens, see, these ends which we are able to see, these ends are negatively charged. Now these ends repel each other. Okay, now what we do, we agitate the clothes. Okay, you know that what we do, we either run them in the machine or we beat them with a stick or we just rub them very hard. So these all things produce agitation. Because of this agitation, there is increase in the ion-ion repulsion. Okay, now when there is increase in the ion-ion repulsion, then what happens, then they start moving away from each other. When they start moving away from each other, then this misli breaks. Now when it breaks, then each and every molecule carries away along with it a very minor part of oil drop. So in this way, oil droplet breaks down, and when it breaks down, then it removes from the cloth, and we say that our cloths have become proper. The dirt has been removed from them. Okay, now see, here you can see, this is the grease, this dark blue color, this is the cloth, and these are the soap molecules. Now they have started making misli. Now here misli has been formed. Now if we will agitate it, then repulsive forces will increase and this oil drop will break, and this will go away with soap molecules. Okay, now there is formation of scum also. So first of all, what is scum and how it is formed? Okay, now see, first of all we should know about soft and hard water. Some water which do not produce leather properly, that is called hard water, and the water which can produce leather properly, that is called soft water. Okay, now how hardness is caused in water? Hardness in water is caused by the presence of carbonates, bicarbonates, sulfates of calcium and magnesium. Now see, these ions you have studied: carbonate ion CO3 2 negative, bicarbonate ion HCO3 1 negative, sulfate ion SO4 2 negative. So if out of these 5 ions, calcium Ca2 positive, magnesium Mg2 positive, if out of these 5 ions any one ion is present, then we will say it is hard water. Okay, now if we use such water for bathing purpose or for washing clothes, then there is formation of some insoluble substance. That insoluble substance which is formed is called scum. Okay, what is the name? Scum. And how it is formed? Because these ions which we said just now, these ions, they combine with soap molecules and they produce that substance which is insoluble. So now see here, in this case this is the scum formed, in this case this is the scum formed. More scum formation means more hardness of water. Okay, so this is called scum. You might have seen in polluted rivers, if you see polluted rivers, there also you can see this type of fog. So that also is scum. Now what are detergents? Now see, detergents are sodium salts of sulfonic acids or ammonium salts of chlorides and bromide ions. Okay, now see, previously our formula of soap was RCOONA. Now this was sodium salt of carboxylic acid. Now here what we are saying, if we take sodium salt of sulfonic acid, okay, sulfonic acid group is SO3H, this is sulfonic acid group. Okay, so if I take sulfonic acid salt or ammonium salt with chloride and bromide, then that will be termed as detergent. Okay, now what happens in case of detergent? If there is detergent, then its formula is such that it will not combine with hardness causing ions, it will not combine with those ions. So it means that there will be no scum formation. Okay, no scum will be formed. Okay, so it means that if our water is hard water, then if we are using detergent, then it will work properly, it will not go waste. Okay, so what we can say, that if there is some hard water or soft water and we are using detergent, then with the help of detergent we cannot tell that this water is hard or soft. Okay, because detergents will work properly in hard water also and in soft water also. Okay, now whatever we have discussed today, on the basis of that you have to solve these home assignments. Okay, thank you.